We've been talking about stoichiometry and limiting reactants, but so far in our lessons, we've just assumed that our reactions go perfectly. That is, that every little bit of product you could make, you do make. This is a little like going into the kitchen and baking cookies. Say your recipe tells you you're going to be able to make 12 cookies. We know sometimes you won't actually get out 12 cookies. Some of that cookie dough might be left behind on the bowl, or some of it might be eaten by your brother or sister, and you don't actually get out 12 cookies. You maybe only get out 10. And in this lesson, we're going to apply that same thought process to chemical reactions. And we're going to learn how to identify how well we've done at running that reaction with something called percent yield. So let's learn about percent yield in chemical reactions. Here's my recipe for 12 delicious cookies. If I go into the pantry and I have a cup of flour, I have 2 cups of sugar, 1 cup of chocolate chip cookies, and all the other ingredients that I need, I should be able to make 12 cookies. But the sad fact is we know that we don't always get out what we should. And in this case, say I go into the kitchen and I only get out 10 cookies. Sad. I lost cookie dough for all sorts of reasons. Maybe I left some behind on the cutting board, but I only got 10 out. Well, how good of a job did I do running that recipe? Well, I can measure that with percent yield. Here's the equation for percent yield. What I do is I take actual yield and divide it by theoretical yield and multiply by 100. But what do these terms mean? Well, let's take a closer look at actual and theoretical yield. Theoretical yield is the maximum possible product you could make from a given quantity. So our theoretical yield in this case was our 12 cookies. It's basically what the recipe says we should be able to make. So here, that was 12 cookies. Now, the actual yield is the yield that happens as the result of a particular experiment, or in this case, a particular time we went into the kitchen and baked. And we saw this time we only got 10 cookies. So our actual yield will always be less than our theoretical yield. And we're going to talk all about how to identify actual and theoretical yield, and then we'll do a practice problem where we calculate our percent yield. Okay, but what about for our cookies? Well, we can calculate the percent yield there, and all we have to do is plug in our actual yield of 10 cookies, that's how many we actually got out, divide that by how many we should have gotten out, which is 12, our theoretical yield, and multiply by 100. If we do that, we'll get 83%. What does that mean? It means we got 83% of the cookies we should have. If our target was 100, we would have just made 83. Our target was 12, we just made 10, that's 83%. Okay, what about in a chemistry example? This question says, a sample of 0.53 grams of carbon dioxide was obtained by heating 1.31 grams of calcium carbonate. What is the percent yield of this reaction? Wow, okay. So if we want to figure out the percent yield, we're going to need to think carefully about how to identify the theoretical and actual yield. Let's look at some tips for spotting those. For the actual yield, remember that it's the yield that happens to result in a particular experiment. So here are some tips on identifying the actual yield. It's almost always given in the problem. So one of the numbers that were given in our problem is going to be the actual yield. It's always smaller than the theoretical yield. We should never get an actual yield that's bigger than the theoretical yield. That would mean we made more than is possible. Not possible. That can't happen. It uses words in our word problems like collected or obtained, made, formed. So to tell us the actual yield, it'll say we collected 10 grams, we obtained 10 grams, we made 10 grams, we formed 10 grams. And remember, it's a yield. It's something we make. So it's always associated with a product. So if we go and look at our problem, we'll immediately spot that the 0.53 grams of carbon dioxide is said to be obtained. Okay, good hint that that then is our actual yield. And notice that it goes with carbon dioxide, which is right here. It's a product. So that's another good sign. Meanwhile, the other thing it gives us, 1.31 grams of calcium carbonate, that actually is a reactant. That's our calcium carbonate. Okay, so we've spotted the actual yield. What's our actual yield? 0.53 grams of carbon dioxide. All right, let's think about some tips for our theoretical yield. Our theoretical yield is the maximum possible product we can make from a given quantity. And here's some tips. Usually we calculate it. So most of the time our problems won't give us our theoretical yield. Instead, they'll give us a way to calculate it. So usually we calculate it. Remember that it's always bigger than our actual yield, and it's also always associated with a product. That means that our 1.31 grams of calcium carbonate can't be our theoretical yield. Why? Well, a couple reasons. One is it's associated with a reactant. So it's not a yield. It can't be our theoretical yield if it actually goes with a reactant. Instead, what we're going to need to do is calculate it. And that's what we'll do in just a second, is we'll go from the 1.31 grams to our CO2. So we're going to calculate how much we should be able to make of CO2 with this recipe. So this is like our recipe. Just like our recipe for the cookies, this tells us how much CO2 we should be able to make. And we know how much of our calcium carbonate we're putting in. And so we'll be able to calculate our theoretical yield. Then we'll plug all that into our percent yield equation. Okay, let's take a look at that. Here, I've broken down the process into 3 steps. First, it says identify the given quantities with specific reactants or products. That's actually a good step whenever you're doing stoichiometry, whenever you're using chemical recipes. This is going to help us think carefully about what they represent. We're told that we have 0.53 grams of carbon dioxide and it was obtained. And so we know that that goes with my carbon dioxide. And that's what I mean in this step, is just identify the particular reactant or product that goes with the masses given in the problem. So we were given 0.53 grams, that goes with CO2. And remember, what we actually have there is our actual yield. So our actual yield is given to us as our 0.53 grams. Okay, and then we also know we have 1.31 grams of calcium carbonate, and that's gonna go right over here, 1.31 grams. Cool. All right, so that's step 1. Step 2 is calculate the theoretical yield with stoichiometry. How do we do that? Well, we just have to go from reactants to products, right? And we're gonna start with our 1.31 grams of our calcium carbonate. That's a reactant, and we eventually want to go all the way to our theoretical yield. And because we're given theoretical yield of CO2, that's what we want to go to, is grams CO2. Okay, so that's our goal, figure out grams CO2. All right, if I want to go to grams CO2, remember that I have to get to moles before I can use my recipe. Just like our cookie recipe was in cups or tablespoons, our chemical recipe up here is in moles, and so I have to go to moles first. I've given us the molar mass of calcium carbonate and CO2 up there. So since we're starting with calcium carbonate, we're going to go ahead and start with that molar mass. And remember, that's saying 100.1 grams is equal to 1 mole. So our 100.1 grams is going to go on the bottom, and our 1 mole will go up top. Okay, now we're in moles. Now we're ready to use our chemical recipe. And our chemical recipe tells us the ratio of things that go out and come in. And here we just have 1 calcium carbonate to 1 CO2. So not very exciting ratios, but this is the stoichiometry step where we go to CO2, 1 CO2, from our 1 calcium carbonate. Okay, so now we're in carbon dioxide moles. If we just stop this problem now, that's what we have. We got rid of our grams, we got rid of our moles calcium carbonate, and we have moles CO2. Okay, so last step then is to go to grams CO2. And we'll go ahead and erase this gram CO2 here, give this a little more space, but we're still going to gram CO2. And so grams are going to go up top, and mole is going to go on the bottom. Here we're going to use the molar mass of our CO2, where we're going to put 44.01 up top and 1 mole on the bottom. Okay, when I multiply through 1.31 divided by 100.1 times 1 over 1 times 44, I'm going to get a yield for my carbon dioxide. It's 0.5759 grams. And that's CO2. Notice now, this number is a number I calculated, and it's bigger than my 0.53 grams of carbon dioxide that was obtained. So that's actually what's going to go down here in my theoretical yield. So now I'm ready to do step 3, which is calculate my percent yield. And when I calculate my percent yield, I'm going to put my actual yield. Remember, that's my 0.53. It's always the smaller number. And I'm going to divide by my theoretical yield, which is 0.5759. And then I'm going to multiply by 100. I should get some number between 0 and 100. If you ever get a number bigger than 100, you know you've messed up the problem. Okay, well that spits out 92.029. And if I think about sig figs here, remember that my 0.53 grams of carbon dioxide just had 2 sig figs. And so I'm going to round to just 2 sig figs here. Because there's a 0 after that 2, that means we round down and we just get 92%. So we did a better job of making CO2, it would appear, than cookies. So that's percent yield. In our next lesson, we'll practice a few more problems where we calculate percent yield. Hey, hey.